you can start sharing. Perfect. Dr. Wilson Rosa serves as Assistant Director at the Department of Homeland Security Cost Analysis Division, and Sara is a Senior Cost Analyst for Galarath Federal and currently supports the Department of Homeland Security. And I'm really looking forward to this presentation. Over to you.
Thank you, Nandi. I'm glad to be back at Kokomo, and this is the first of the series, and I hope to be coming back next year. What I want to share with you and for the Kokomo audience is a way to build cost estimation model for Agile programs using data that you might already have. I always say it's not rocket science as long as you have the time, the people to do it, and also your desire to break grounds in building something new. Next slide. So this is a lineup for this presentation. I'll begin with providing a general overview of the research framework, followed by the data analytics. Spend a little bit time talking about the effort model results. And last but not least, discuss the results and also how can this be adapted to your work environment, whether you're a contractor, government, or academia. Next. It doesn't matter what agency you work for, whether you're a contractor, private sector, academia, we're all here because we have the same need. We're trying to find ways to improve the state of cost estimation for Agile. The $2 billion Powerball question, probably unfortunately happened in California, is how do we get there? Now, next slide. The good news is that we have something to offer you today. We will give you access to open source cost and schedule models built from real data that you can use in many ways. If you are a developer, you can use these models for cross-checking your estimate before you submit a proposal. If you're in the acquisition or financial management, you can also use these models to establish your baseline budget. Or if you're tracking performance of a developer in progress during the implementation phase, you can develop estimates to check whether that developer is forecasted to meet or slip schedule. Next. We also have good news for those in the program analysis or program manager. These tools that I'm about to offer you and show you can also be good eye-opener for program managers. It doesn't matter what stage you are at in the life cycle. You can choose any of the size measurements in green below for developing your next or upcoming estimate for any project of your choice. Now, for the purpose of this study, we're capturing 6 size measurements. The 3 in green to your left, capability gaps, capability, and epics, that is something that we have, but we're about to show you in the upcoming months. And these are more like early inception phase metrics for Agile that could also be applicable to private sector. Next slide. In the Department of Homeland Security, Agile has been around for about 12 years, but our efforts, the Cost Analysis Division, to improve the state of cost estimation began roughly in 2019 with the inception of the Joint Agile Software Innovation Cost Integrated Product Team, known as JASI. And today, 3 years later, we are sharing with you costs, tools, and best practices built from real data, and also ways to replicate this model for those of you that are non-government. Next slide. Our findings and our analysis also represents a breakthrough in many ways, but most importantly, it introduces 3 new size variables that have been not explored before: functional story, issues, and user stories in the context of Homeland Security and DHS and DoD. At the end of the presentation, you'll find out also that we will be able to show you and compare these models for these competing size measurements, and you'll find out which of these are more accurate as a predictor. Next slide. Now let's talk about the fun part, data. Now, getting the data was by far our most time-consuming effort. Our efforts to collect data began during the initial stages of the COVID-19 pandemic around March 2020. And what made our data collection successful was the approach. Our ability to engage with program managers and persuade them to provide data. One revelation from this study is that our efforts prove that collecting data in a virtual environment, in our case, like using Microsoft Teams, proved to be far more cost effective than the traditional time-intensive travel in-person data collection. So, and this is evidenced by the fact that every single program manager that we contact gave us data. And as you can see, we ended up with 18 Agile programs. And by looking at this bar chart, most of them are very relevant, done in the last 3 years. Next slide. Extending our discussion on data sources, and this is advice for those of you that are embarking on research on Agile. When collecting data, make sure you know what you want before you engage with the program manager. Since program managers don't like lengthy surveys, I hate them, we try to employ a different approach. What we did was that we said to program managers, we know you're busy and we want to collect data in an unintrusive way. Give me whatever you have and we will review it, normalize it, and only get back with you should we have questions. And out of that approach, we said, give me 6 basic data sources. And these are monthly contract invoices, requirements documents in the form of requirements traceability matrix or functional requirements document, the product backlog in Jira or some other form of logistic management tool. Also, any acquisition document that provided description of the system characteristics and the Agile framework. And also, as a lessons learned, if you answer these documents shown here, guaranteed that you're going to get more data than what you need for your research. The flip side of this is that it's an overkill. It takes a lot of time to clean the data, to correlate, to normalize and standardize. But the gain and the big benefit of using this approach is that having access to raw data, authoritative data, and doing the normalization yourself by the same team consistently, in my experience, you'll see the result later, it dramatically increases the integrity and the quality of the data set. And I call this data analysis 101. Next slide. For selecting the variables, we didn't use any best fit analysis and none of that statistical, I'm not gonna say the word. We use common sense. We pretty much said, okay, what are the variables that we can possibly get from the 6 documents that I referenced in the previous slide? So we ended up with the 9 variables you see here, 6 for size, 1 for effort, 1 for schedule, and also we had a stratifier on the bottom, categorical, to distinguish between programs that were enhancements and those that were full-scale development. Next slide. So I said earlier that collecting the data was the most challenging task, but the second worst was normalizing the data. One challenge that we faced was how do we measure labor hours? Measuring labor hours for Agile, what I found the hard way, is very different from what you are accustomed to see from DoD and industry. In this study, we captured the total labor incurred by the Agile contract developer, which includes the 11 elements shown here. That is above and beyond what you get in traditional models that only includes software development labor. And why we did that? Very simple. The choice for using total effort is driven by the fact that the vast majority of projects Agile within the Department of Homeland Security are either fixed price or times of material. And these generally don't break out labor by the typical cost elements you see in your traditional cost plus contracts. And I think that one main takeaway here for future research is that Capturing total labor at the aggregate level for an Agile program is far more convenient and considered the new norm for Agile. And you'll see later how does this translate into accuracy. Next slide. Of the variables that we considered in study, there were 3 that were not given to us: functional story and the 2 forms of function points, simple and unadjusted. None of these were given to us. So we had to hire a certified function point specialist to derive the count for us for each project. And we derive these counts from either 3 different sources: requirements traceability matrix, functional requirements document. In some cases, we had to derive that from product backlog. For the first 2, it was easy, straightforward. But when we had to count function points and functional stories from product backlog, we had to be a little more disciplined. And we employed a 4-step process where you see here. And one hint for you is that this could also apply to private industry and academia, because the fields that we use for stratifying the data and analyzing in JIRA are standard fields. And these can be replicated for any programs outside of the government. Now, the first thing we did in converting to these size measurements was once we got the product backlog in JIRA, we selected column issue status and filtered by those that were marked as either completed or done. The second step, you go to the column issue type, and you filter by those that are marked story or user story. That's also simple, but caution, step 3, categorizing each story as either functional and non-functional was not a piece of cake. And to me and to my team, this was by far the most critical step. And my view is that you don't get it right, doesn't matter what automated tool you do for function points, because it's going to end up being garbage in and garbage out. Now, one thing for recommendation and suggestion, step 3 can either be done by the product owner, a developer from the Agile team, or like in our case, because we didn't have access to these 2, we relied on our certified function point specialists. And once you did step 3, it was a piece of cake. Step 4, we did it manually, but for those of you that are embracing machine learning for function point count, step 3 is where it's highly recommended. And these were the 2 pain points for data normalization. And this concludes the data conditioning part, which is a little bit not ugly compared to data analytics. So that concludes this part. Now I'll turn it over to Ms. Sara Jardine, who will talk about the fun stuff, the data analytics. Thank you.
Thank you. Just going over some of the data set demographics, just to get started. Most of this is a reminder. Our sample size was 18 IT projects, 3 of which were DoD Navy projects, and 15, the majority were DHS IT projects. They were all classified as automated information systems. Majority used Amazon Web Services for their cloud. In terms of the contract type, majority, 15 of those projects used either firm fixed price or time and material contracts. And then in terms of the iterations, it was generally between 2 and 4 weeks. Next, in talking about the data set demographics of our 18 point data set, in terms of the framework, majority, 13 of them were Scrum, while 5 of them were Kanban safe with those larger teams. In terms of the team approach, it was about even. 10 were Sec DevOps, and then 8 were DevOps or Dev only. Now let's look at the descriptive statistics of the dependent variables. On the left-hand side, we have effort hours, which was our first dependent variable that we evaluated. And then on the right, we have software development months. We show the minimum hours, the median, mean, and then maximum and standard deviation for both effort hours and software development months. When you take a look at the average for software development hours, we averaged about 117,000 hours, while we averaged about 18 months in our data set for the software development duration. Now let's look at the descriptive statistics for the independent variables, so our size measures. We show for the functional stories, issues, stories, story points, unadjusted function points, and simple function points. We show the minimum, median, and maximum values. So when you're evaluating these models or using it for an estimate, you want to make sure that you're in the relevant range for your independent variables. So is the estimate that you're doing for your IT software development, is it comparable to these independent variables in terms of the relevant range? So the relevant range was anywhere from 20 to 5,000 stories, 10 to 2,000 functional requirements, 80 to 11,000 function points, and then 9 to 200 peak staff full-time equivalents. Now we show you the results of our effort and schedule models. First, we wanted to offer benchmarks. In terms of the benchmarks, we show for effort hours, we show hours per functional story, hours per unadjusted function point, and hours per simple function point. We provide the 25th quartile, the median, and then the 75th quartile, standard deviation and coefficient of variation. These benchmarks can be used for a cross-check that you're using for a cost estimate on software development, or it can be used for risk bounds in a risk analysis. We also show a practical application example where if you had 200 simple function points, you could multiply by the appropriate effort benchmark and derive your effort hours. Similarly, for schedule benchmarks, we show functional story per FTE per month, unadjusted function point per FTE per month, and then simple function point per FTE per month. Similarly, we show the 25th quartile, median, and 75th quartile. You can also use this for a cross-check or risk boundaries in a schedule risk analysis. And then we show the same practical application example where you had 200 simple function points and how to derive the number of schedule months using your benchmark. Now let's talk about our effort estimation, cost estimating relationships that resulted. The results you're about to see, all these effort and schedule models, were derived from COSTAT, regression analysis. That was the software tool that was used, which is the tool that we have on hand at DHS. I'm going to show you 6 effort estimation models using those 6 sizing measures. In this first slide, we show functional stories and we show stories. So when you look at the two and looking at the resulting statistics, you can see that functional stories did perform better than stories, although both were statistically significant. Next, we compare the statistical results of issues and story points. When you look at these statistical results, you can see that story points did outperform issues. And then the last 2 sizing measures were unadjusted function points and simple function points. When looking at the statistical results, both were pretty high. Simple function points slightly outperformed unadjusted function points, but we did add the dummy variable as noted for scope in the simple function point CER, where we did distinguish between full development and enhancement. So that was a dummy variable that needed to be added into the simple function point equation to predict effort hours. Those were the 6 effort estimation models. For schedule estimation models or schedule estimating relationships, we had 3 that were statistically significant. It was functional stories, unadjusted function points, and simple function point. For the scope dummy variable that differentiated between full development and enhancement, this was a dummy variable that had to be included in the equation in order for those independent variables to pass statistical significance. So without that dummy variable, we didn't achieve the statistical significance to actually use that schedule estimating relationship. So you'll see in the schedule models, that dummy variable needed to be included. When looking at the results, you can see that most of the statistics are roughly about the same. They all performed about 88% for the R-squared, so all were relatively high in terms of statistical significance. Now let's look at how did all these models rank against each other. This is a table that shows most statistically significant to least statistically significant. The results of the ranking show that anything based on functional stories for both effort and schedule outperforms the more popular Agile measures such as story points, and issues. Let's talk about our results. In terms of model limitations, some internal threats could include that the dataset timeframe was from 2014 to 2021, which may raise issues for those earlier projects that may have used Agile processes that were more tailored to fit the agency's need. External threats include these models were effective in estimating Agile programs in the DHS context, and we couldn't necessarily generalize beyond the DHS agency and generalize it across all federal agencies. Other agencies, for example, may not have access to a product backlog, FRD, or RTM to actually perform simple function point analysis. So that could be another limitation. In terms of constructive threats, we are aware that this is a small data set of only 18 data points, although it took 2 years to collect since it was a raw data collection effort. And we couldn't necessarily, it would not necessarily allow for the greater estimating power, and there could be a threat of overfitting. So we're aware of that. We are aware that we may need a larger data set to draw more confident statistical conclusions. What are our main takeaways from our study? The first is we now have a wider range of sizing measures, 6 sizing measures to be exact, to estimate future Agile software programs and to evaluate contractor proposals, including schedule. Next, simple function points and unadjusted function points proved to be the most accurate predictors of Agile software development effort and schedule. Our analysis revealed that the functional story is an effective predictor of effort and schedule while it's easy to obtain. Popular Agile sizing measures such as story points, stories, and issues are also not as effective predictors of effort and schedule. Simple function points and unadjusted function points can be calculated early in the program, allowing for estimation all the way from contract proposal through IOC, while those other popular Agile sizing measures may be more difficult to obtain. And that was the last slide, and we're open to any questions.
I think we are good. Just a reminder to everyone that all of the presentations will be available at the close of the forum. I am recording individual presentations, which also will be available after the forum is done. It looks like we are somehow ahead of schedule, which in 16 years has not happened. So thank you, everyone. If there are no other questions, I will keep this room open. We will be back at 11. So hang out. Thank you so much. And we'll see you in about an hour.